Hi, I finished my last video in around 94-95 when the Amiga and Atari died. I planned to make something about PCs. My original plan was to measure multiple 386 motherboards and compare them, but after working on it for a week or two, I changed my mind. To be honest, I collected around 24 of motherboards, CPUs, whatsoever, but finally I figured that out it is not as interesting as the period itself. For me, it was a kind of flashback when I found the motherboard, the 386SX motherboard, what I had during 1994. You may say that in 94 it was really outdated, that's true, but let's see why I had this kind of motherboard, how it behaved, what I put together, and of course few benchmarks and games as well. Just to put you in context, my family lived in Eastern Europe that time. The Iron Curtain was lifted and it was free to trade with anything. It was in one hand very good, in the other hand the whole country was really poor. I do not mean that in the sense of we had nothing to eat, but I mean in the sense of wages. The average salary in West Germany was over 2000 Deutschmark, but for our country it was around 500 Deutschmark. My father spent a lot of money on computers, so we were a kind of exception in that sense. Of course, he saved this money somewhere else. So I had a C64 in early 93 and he had an Amiga 500. As a teenager, I had summer job and worked a little bit beside the school to save some money. I sold the C64 and with all my savings, I started to look around for a new computer. I had two options. I could buy an Amiga 1200 or build a PC. It was a hard decision to go for the second one because the Amiga was much closer to me. But I had not enough money to build a brand new fast computer, so I started to buy piece by piece my computer and put it together. At the end of 93, I had multiple options. The first option was to buy something at 286 and pump it up. It could fit my budget, but I aimed higher. That means I aimed for a 386. On top of the lower salaries, computers were more expensive here. I don't know how could it happen, but if I compare advertisements from the West and from here, then it is quickly visible the Hungarian prices are much higher. The exchange rate between Deutschmark and Hungarian forint was somewhere around 1 to 56, but we need to add the VAT, which was 25% that time. What kind of 386 manufacturers and CPUs were available that time? So first of all, there was the 386SX. On this motherboard, I have an Intel variant. This is running on 33 MHz. But there was an alternative from AMD. AMD made the very same, but running on 40 MHz. There were two variants of the 386. So the SX is the reduced version of the DX. What does it mean, reduced? Intel cut the data bus to 16 bits and the address bus to 24 bits. It is possible to build cheaper motherboards with these CPUs, but of course this cut reduced the available memory size, so the maximum address space is 60 megabytes, but it was more than sufficient at the time. But the reduced data bus also meant that it reduced the bandwidth to half. It is easier to see the difference between the two CPUs if I put next to each other the two variants. As you can see, there are more pins on the DX variant. There were more alternatives. Cyrix also produced CPUs. They call their own CPUs to 486 DLC. This CPU is fitting into the 386 DX socket. Even if they call it as 486, it is not a full-scale 486 processor. It has 1 kilobyte internal cache and it can execute the additional instructions, but to be honest, it is not as fast as a normal Intel 486 SX or DX CPU. That time everybody said if the 486 DLC is running on 40 MHz, it is a little bit faster than the 486 SX, so an Intel variant, running on 25 MHz. Of course, Cyrix made its own SX variant. It is called 486 SLC. The internals are the same, so it has also 1 kilobyte of internal cache. In the benchmark, you will see how much can it help to get over the limited bandwidth because of the 16-bit data bus. If you take a closer look, you can see it is badged and Texas Instruments. It is because TI made the CPUs for Cyrix, and they sold the very same CPUs under Texas Instruments logo. Cyrix and Texas made other versions, for example, the DRX2 with doubled clock speed, or other variants with more cache, but those are quite rare. But I would like to mention one more 386SX pin-compatible CPU. It is coming from IBM, and it is called 486SLC. In fact, there is no connection at all between the Cyrix variant and the IBM variant. The IBM variant is based on the Intel 386SX. IBM licensed the CPU core and pumped it up. They made a lot of changes. For example, this variant is a clock doubled version. It can run up to 66 MHz and has a 16 KB internal cache. This is a small beast, but it arrived too late to the market to make any difference. There is also a mathematical coprocessor on the motherboard. That time it was not really a usual thing. Only a few DOS programs used that. Internal FPU was introduced only with the 486DX. So none of the CPUs has an internal coprocessor. But that time, all the motherboards had a socket for them. As you can see, this FPU has pins as well as the 386DX. And to install it to the socket, we just need to align it. So find the marking, match it with the socket. Okay, I do not push it right now, but this is how we would fit. But what about the 486SX? I have a motherboard for that. I have a combo board. So this is the 486 socket. It was the time when they introduced these zero insertion force sockets. I just need to open it. Need a CPU, find the first pin there as well. Okay, here they are matching. Insert the CPU and just close the lid. That's it. Or because it is a combo motherboard, I can install a 386DX, of course not at the same time, but it makes easier to compare the two CPUs. To change between different CPUs, I have to set a lot of jumpers. So I have jumpers here at the front and back there and almost everywhere, here, there. So to set all the jumpers, it takes a lot of time and you have to really double or triple check before you turn it on. It was not as simple as today, but I really like it because it reminds me for the old good times. There are a few more components on the motherboard. So there are the cache chips. I'll come back to those later on because this is a special kind of motherboard. It has fake cache. The memory can fit into different sockets. So either I can fit 4 times 9-bit C modules, or I can install FPM modules. Those are 32 bits or with ECC 36-bit wide. If you make a quick calculation, I need 4 of the older modules because 4 times 9 bits is 36 bits. This is true for the 386DX machines, so for the DLC as well. For the SX machines, I can install memory modules in pairs. So 2 times 8-bit is 16-bit, the 16-bit data bus. So I can install either 2 or 4 modules. Which means depending on the memory module size, something between half megabyte and 16 megabytes. So we have motherboards. Let me build a machine. First of all, we need a power supply. Of course, it requires some kind of button to turn it off and on. That time it was a normal switch. The motherboard connector differs from today's standards, but all the rest is the same. So if you check them out, you can find in almost any PC today. As I mentioned, I found the motherboard I used to have. Of course, this is not the one, but this is very same. So I will use this one, but let's check out the other components. So first of all, we need some memory, 4 of them. So it will be 4 megabytes. A video card. This is a Trident with 1 megabyte of memory. This is pretty decent. It is one of the fastest one. I choose an ESS-based sound card simply because this is what I used to have. This is a compact made jumperless version. It is working pretty fine. I can connect it to my system so I can record the sound. It is just working. I also need a card for the storage. As you can see, the cable is already connected. This is for the hard drive. and there are more connections because this one is a multi-IO card. So I can connect floppy drive if I need, also serial port or parallel port. I will use the serial one for the mouse. But what is more important, as storage I will use a CF card. I have this adapter. It makes easy to transfer data between my workshop machine and this computer. What is also interesting, the size of the card. It is a 4 GB variant, but these old PCs support hard drives just up to 504 MB. Later on I'll show you the BIOS settings as well as how I get around this issue. Okay, one more thing is coming into my mind. This is the motherboard size. As you can see, this one is a pretty neat small motherboard. This is called Baby AT. So as you can see, this one is just a bit longer, but I prefer this small one. Okay, let's put it together. First of all, the memory. There is a cut. I just need to align it properly. You shouldn't force it, it should click into position. Always check out the chopped side and start it from the proper side, otherwise it won't work out. Okay, I do not have an FPU. The next one is the video card. Just firmly push it inside, as well as the sound card, and of course the multi-IO. The last one is the power cable. The ground should match the ground, so the two black sides should match each other. Take care of it. Sometimes it is a bit tricky, it is harder to connect. I already mentioned the mouse, but I would like to show you something. So this is a really old one. If it is a bit jerky, you just need to open the lid, so rotate it, and you can clean it. It is using a standard serial connection, so I just need to connect it to the multi-IO card. Okay, it is done. So what else? I need a keyboard. It has the old connector, so this is the 5-pin DIN connector. I just need to plug it in. Of course, I need a monitor, so I need to connect the monitor. It is using the standard analog VGA, so still it is pretty easy to find a monitor for that. Everything is connected. Let's turn it on. Of course, I'm getting some error message. There are two reasons. First of all, nothing is set. The second one is I do not have a battery on this motherboard. I remove the battery because this is the main killer of these boards. If you buy such board, make sure you remove the battery. As well as if you see any sign of the leak, clean the motherboard. Just use alcohol or passivate it, no matter how, clean it before it kills. As you can see, in the meantime, I enter to the BIOS and let's check out the standard CMOS settings. This is where I can set the date and other stuff. What is the most important for us? To set up the hard drive. I set a user type and I'm setting my own settings. That way I have 472 megabytes. Well, this is more than enough. Okay, I lose a lot, but it is working. Since I do not have a floppy drive, I just simply remove it. Okay, let's check out the advanced settings. Again, the floppy drive, so do not seek, and these settings are speeding up the boot process. It is possible to set up the shadow, which is default enabled here. What shadow does, for example, if we have a VGA card and there is an EPROM, which is quite slow because we reach it through the ISO bus, so it is with a lot of wait states, then it copies to the internal memory and speeding up the access. I'll just leave it as is. Okay, advanced chipset setup. Well, it is very limited. I just reduced the slot refresh and increased the refresh speed, so it will consume less time. There will be more bandwidth for the CPU. If you benchmark it, the difference is somewhere between 5 to 10%. But also it can cause instability, so it requires some testing if you change these settings. There is one more thing to mention. There is the hard disk utility. So if you use an MFM hard drive, this is the point where you can format it. It means a low-level format. You can set the interleaving, which means you lose all the data on the hard drive, but it can increase the speed. You may ask, who is that crazy to use a MFM hard drive with a 386 machine? Well, it was me, because I had no money for the hard drive. So my budget was that limited. I went for the 386SX with more memory, but with a very old, slow hard drive. But this is what we liked in the box PC, so it was really easy to replace any part of the computer, add more memory, replace the sound card, the hard disk, the VGA card, so it was easy to expand it step by step. Okay, let's save the settings and boot it up. Starting DOS, this is a good sign. HiMem is testing extended memory. Let's check the memory. I have a lot of base memory. If you don't know what I'm talking about, in the old days for the DOS, there was the base memory, which was the famous 640 kilobytes. There was also expanded or extended memory. Theoretically, the 386 CPU can address the whole memory. In practice, because of backward compatibility, we still have to deal with these different type of memories. For that, we have to load extensions, so kind of device drivers. That time we call them TRS. No matter what, let me show you my config.sys and autoexec.bat file. As you can see, I'm loading the HiMem.sys from the Windows on the first line. This is handling the extended memory. And there is the second line, which is for the expanded memory. This is what we also called EMS, but in my case, it is not active. If you activate the EMM386, you lose around 5 to 10% CPU power. There is one more line I would like to mention. This is the dossier hi, UMB. This is instructing the HiMem.sys and the DOS together to try to relocate part of the DOS there. That way we have more space in the base memory. Let's check out the autoexec.bat file. This is executed automatically during the boot. So the first line is loading the ESS configuration program. If you say this is a driver, it is not. This is just configuring the registers of the sound card with the given values. There are cards with jumpers. There you don't need this first line. You just set it with the jumpers and that's it. The second line is setting the blaster environment variable. This is used by a lot of games and other programs to detect the sound card and its settings. The third line set the path variable. If I type a command, this is where the DOS tries to find it. So it makes sense. I can put to different directories, different batch files and programs and sort them. The fifth line is starting with LH. This means load high. So the HiMem and the DOS tries to load this mouse driver to the high memory. This TRS program is the closest one, what we call as driver. Before the benchmark results, I would like to show you how I built the 486 DLC and 386DX based machine. I don't want to waste a lot of time with that. There are only 3 interesting parts. The first one is jumpering. I have to set up a lot of jumpers, and even if the manual is clear, they really spread it all over the motherboard, and the numbering of the jumpers seems just random. The second thing is the cache I already mentioned. It is a fake cache. I can do anything. I can remove the cache from the motherboard, I can add more, I can change the jumpers. It doesn't matter. The BIOS startup screen shows whatever I do, 1024 kilobytes of static RAM. Also, the benchmark results doesn't change if I enable or disable the cache. It was also common to sell a motherboard with 8 kilobytes of cache, but in fact, there was no cache at all on the motherboard. So all in all, this is what we call fake cache. The third thing is the VESA bus. This bus system is 32-bit wide. It is connected directly to the CPU. As you can see, the VGA card is much longer. I executed benchmarks with multiple cards. I used the older Trident, the 8900. The second card was this new Trident, and you may observe the S3 on the right corner. Unfortunately, the screen of the faster Trident is not stable, so I could make records only just with the older Trident and the S3. At this point, I'm reaching the benchmarks, but I think I cannot present all the results to you. It is because I have too many measurements and benchmark results I can present. If I compare the results of the 386SX motherboards, then it is somewhat disappointing. As you can see, I have CPUs from 25 MHz up to 40 MHz, and I have 4 different motherboards running on 40 MHz. There is around 20% difference between the slowest and the fastest motherboard. Additionally, the TD70AN, this is the motherboard I used to have, is the slowest one from those 4. I made a chart only about the Wolfenstein and Doom results. I choose these ones because these were real-life games we played a lot. But let's check out if the 1 KB cache of the 486 SLC helps. The results can be compared directly because here I use the very same motherboard with different CPUs but running on the same clock speed. It is clearly visible the cache helps a lot, but it really depends on the workload. For example, 3D Bench, Drystone and Whetstone results are very consistent. I repeated Wolfenstein benchmark many times because there I just got 118%, so the increase is just below 20%. On the other hand, Doom is really profiting a lot from the cache. When I disabled the 486 SLC internal cache, the results are dropping back somewhere around the same level as the 386SX. All in all, a motherboard with the SLC was really faster than the SX. But what about if I use the 386SX as the base, so this is the 100%, and I compare to the faster models? This chart is similar to the previous one because it is showing the same dependency on the code we are executing. There are a few trends. First of all, I would like to pick up the IBM 486 SLC because this is the fastest one. Of course, it has a clock speed advantage because it is running on 66 MHz, but I think the 16 KB internal cache helps this CPU a lot. It is also interesting, there is no big difference in the Drystone results between the 486 SLC, 386DX, DLC and the full-scale 486SX. Also, there are a few tests where the 386DX suffers because it has no internal cache. There are many cases where the 486 DLC is way faster than this CPU. Based on these results, I have more questions than answers. Back then we said the DLC running on 40 MHz is somewhat faster than the 486SX, but if I take a look at the Doom, I'm not really convinced. I think many benchmarks use smaller iterations. Those can be fitted into the smaller internal cache, and this is the reason behind why they are giving much higher result than the reality. But what about the VESA local bus video card? That's a good question, but I have to say the same as before. It really depends on the workload. If I'm using the Wolfenstein, the advantage is around 20%. This is the point where the older VGA card is getting to be a bottleneck. But for example, under Doom, it is not really improving, so jumping up from 8.7 to 9.4, this is not even 10% increase. But there was a use case which could benefit from the newer card. To be exact, it was not because of the faster bus system, but because of the chip on the new card. The S3 is able to support the windows to move the windows, fill it up with different colors, and it can speed up similar operations. And that way, especially if we use higher resolution, it can speed up Windows a lot. But let me switch over from benchmarking to my favorite topic. So what about games? What kind of games we used that time? Of course we played Doom, but my computer was not fast enough to run it in full screen, so I had to reduce the screen size to somewhere a quarter of the original size. As you can see, it is still sluggish. By the time it was the level, what we considered as playable. But Doom was not my favorite game, so let's go through my top 3. I really liked strategy games, I played Dune, but I selected here the XCOM. I cannot count how many nights I spent to kill those alien bastards. After killing aliens on Earth, let's switch over to the space. X-Wing was very fascinating and sometimes very annoying as well.
Target destroyed. Roger, using designated target.
Most of the LucasArts games were really very good, and there is one more to mention, Day of the Tentacle. This is the point where I'm closing this video. I hope you found it interesting, enjoy the intro of the game, join me for the next video, goodbye.
I'm thirsty.
I don't think you should drink that. It looks bad for you.
Nonsense. It makes me feel great. Smarter. More aggressive. I feel like I could. Like I could. Like I could. Take on the world.
Look, Hoagie, it's a hamster. Just what I need for dissection lab tomorrow.
I think I need that for the band, Laverne. You know, like we could bite its head off or whatever.
Hands off that hamster.
Friend of yours, Bernard?
He belongs to Weird Ed Edison, and it looks like he's brought us a note. It's from my old friend, Green Tentacle. He says that Purple Tentacle's mutated into an insane genius, and Dr. Fred's going to kill them both. I thought I was free of Dr. Fred and those crazy Edisons forever. But now I know that I must go back to the mansion.